In my past life, I sold material lumber. I met a man who was building a casket from a tree that he planted when he was 5. I had a 2-hour drive home. I asked myself, what have I planted?
I said, I want to see something new every day, and I want to realize something new and find something to apply to good stuff, something of significance, stuff that's important.
I was very motivated by the environment and was always intrigued by the ability to use science to make the world better.
We're passionate about, first and foremost, taking care of the planet for others who are both living and thriving now and those who will come after us.
All across the country, everyday Americans are meeting the challenges of today with the innovations of tomorrow. In the spirit of Benjamin Franklin, Thomas Edison, the Wright brothers, and Henry Ford, we're rolling up our sleeves and getting straight to work, inventing solutions to build a more resilient, sustainable world for everyone.
When we talk about sustainable, we're really talking about the big business picture, the business of living on Earth.
This climate change battle is something that it's massive. It's the largest challenge that humanity's ever faced.
And you can debate about the causes of climate change, but the reality is it is happening.
It used to always be hot and humid. Now it's broken that barrier. So the temperature and humidity are at a height that they didn't think was possible before.
In America's hottest city, researchers at Arizona State are doing what some say can't be done, attempting to control the weather, or at the very least, beat the heat.
Heat is everybody's concern, but hasn't been anybody's responsibility. When we look at the health statistics across the whole country, heat kills more people every year than almost all other hazards combined.
There's a lot more people studying the problem of extreme heat. The more data you have, both health data and weather data at finer scales, the more we can know about what's happening to people in the places they live.
Marty is a robot that can measure how you experience heat. So when it's sunny, Marty can tell you how miserable you are.
In order to make these things more realistic, we are getting a thermal mannequin named Andy. It is an incredibly advanced instrument that has 35 different surface areas that are all independently controlled, and each one can sweat. We can push it to overheat, so to say, more than we can do with a human trial. We might be killing Andy, but we have a full service contract, so it's okay.
You can actually engineer surfaces that have spectral reflectance characteristics so that they look the color that you want, but they're still highly reflective to the sun's energy. So if I take an infrared image of this with this camera, you can actually see that one of them is much hotter than the other.
That's incredible. That's blowing my mind.
The big vision or goal is that we could actually reduce the air temperature in the city, especially here in downtown Phoenix, where we're at the epicenter of the urban heat island.
When we think about who's dying of heat, it does have a lot to do with those unhoused living on the streets, or those who are housed but living without air conditioning, or they can't afford their air conditioning.
We're seeing a housing affordability squeeze that is pushing more and more people onto the street each day. And every one of those people are at risk. I do think we need to be creative to acquire additional structures and real estate that can serve as more permanent relief.
And fortunately, across the country at the University of Maine, a very creative housing solution is on the drawing board, or shall we say, in the printer.
We have a special type of 3D printer here. The pellets we use can be made from lots of different kinds of materials. We're trying to utilize resins that were derived from natural products and get a 100% green bio-renewable feedstock that can then be converted to use for tooling or objects, houses, boat molds, etc. We're just trying to make them better, cheaper, using less energy.
We have a huge housing crisis throughout the country. If we can actually reduce the weight to near zero and use green materials to build these homes, make them very well insulated, and deliver them faster to the population at the point of need, where people need them. That's where we're trying to go.
When you bring those two together, then you're 3D printing, trees or whatever it comes from. So in that instance, it's fully bio-derived, fully recyclable. That's kind of the holy grail.
Not only is this a brilliant housing solution, it's a brilliant waste solution.
We're trying to mitigate any plastic waste going into the environment. You're creating less waste from materials that don't have to, at the end of their life, go to the landfill.
The average American throws away 4.9 pounds of trash a day. Just plastic alone, we throw away enough to fill the largest NFL stadium in the country every 15.5 hours. But what if we could turn our trash into treasure? Throughout the nation, innovators are looking at waste in a whole new way.
How can I take a waste product and do something that's environmentally better by taking a product that would decay and off-gas all its carbon, and instead we'll use it and store that carbon. Carolina Urban Lumber is a company that revolves around making product from an urban waste log. We partner with probably 10 major tree services. Their waste product at the end of the day is our commodity. We give people options to get furniture and lumber that didn't travel more than 10 miles in its entire life. There is a circular nature to this.
And speaking of circular, Carolina Urban Lumber is a member of the Innovation Barn, a Charlotte, North Carolina development hub focused on building a circular economy, connecting them with like-minded companies like Crowntown Compost, who are tackling another kind of organic waste.
Our core is getting food waste from households and businesses out of the trash, so we don't let it go to the trash in the first place. A black soldier fly composting operation eats a bunch of food waste, multiple times their body weight in food waste, versus like traditional compost with producing a soil amendment. It keeps a lot more of the nutrients and the actual mass in that cycle.
Yeah, so this is actually in the composting process right now.
It's like noticeably warmer.
I feel it.
Part of the warmth is the food waste and microorganisms digesting it, but it's also the black soldier flies digesting it.
That's incredible. I mean, it's really, really cool. It is disgusting, but really amazing.
Composting food to become healthy soil to grow more food is just one of the ways Americans are reducing waste. In Salt Lake City, Wasatch Resource Recovery is converting food waste into natural gas.
So that's the digester right there. We have the same microorganisms in our bodies that we have in those digesters.
Right. It's like a giant stomach?
It is like a giant stomach. Yes, it works much like a human digestion system. The goal is to put all of that food waste in contact with the microorganisms that can break it down. And it's during the course of that process that gas is created, and ultimately we're able to capture that gas, clean it, and send it to the grid. When we're operating at full capacity, we'll be able to produce about 2,400 decatherms of renewable natural gas a day. And that's enough to provide natural gas needs to a community of about 30,000 people.
However you're powering your home or charging your new EV, affordable electricity is something we all are looking for. And that's why so many American innovators are focused on building a more resilient energy system.
About 14 years ago, the energy prices shot up through the roof. The average family in Maine was spending close to $10,000 per year just on energy costs. That was our mission. How do we transform our energy system in the state of Maine?
The goal of this offshore wind program is to start small with single turbines, but eventually build an offshore wind industry in the state that will provide enough renewable energy to power the state and create thousands of jobs in the process.
We've invested hundreds of millions of dollars on our hydro infrastructure, but realistically, we're at about 2/3 utilization of our hydro generation potential with water spilling over the dam.
Renewable energy is inherently intermittent. When the sun's shining, that's the only time we can get solar. We need electricity all the time. Energy storage solves that problem.
I got a call from a friend. He said, hey, I got this great idea. We should take inactive oil and gas wells and convert them to energy storage devices.
At the end of the day, I would sum up Artemis Prime as a fancy regenerative winch.
When you spin it one way, it makes power. And when you spin it the other way, it consumes power. So as the weight descends, it's making power. We're pushing power to the grid. And then when the weight gets to the bottom of the well, we pull power from the grid and reel it up. It's strictly a mechanical battery. It's more akin to a hydroelectric dam than anything else.
I think that it's the best solution to the energy storage that I've seen. Plus, it also uses the secondary aspect of being able to use wells that should be sealed up and the methane removed, so it has a double benefit.
We're taking something that was a visual and environmental blight and making it something beautiful.
Finding a way to store energy over the long term or be able to use it at will is really what the future has in store for us.
Beneficial electrification is using electricity to displace oil so that the money stays in your local economy, isn't exported with each empty oil barge, and that nobody loses from the proposition.
Chances are you're seeing beneficial electrification every day. With 8.5 million electric vehicles on American roads, projected to grow to 26.4 million by 2030, and major automakers pledging to go all electric by 2035. And EVs aren't just fun to drive. They make sense. Dollars and cents saved at the pump, saved in our carbon emissions. They're a powerful way to clean up the air and get us where we need to be now and way down the road.
Mobility is a huge consumer of energy. It's also a producer of emissions. We're looking at the entire vehicle traffic infrastructure all the way down to how can we improve the cell chemistry of an individual battery.
We're really interested in understanding how we can provide more sustainable transportation systems.
In a perfect world, my thought would be everything should be electric. We shouldn't need internal combustion engines anymore. I think that future's closer than we think it is.
How do we provide the charging capabilities for EV owners to be able to operate and drive their vehicles with the same level of flexibility and peace of mind that they've done for decades with internal combustion engines?
Ubiquitous charging. Our goal is to actually send power from a roadway to the vehicle. It's all through electromagnetic fields. It's not unlike if you have a cell phone and you place it on a charger. The only thing that's different is you're going out across a large distance from the roadway to the vehicle.
You don't need to stop and charge your battery. You're going to drive down the road and the road's going to do it for you.
While electricity is in the lead for powering the future of transportation, alternative fuels are another contender, and they could help us use our renewable resources even more efficiently.
If we can take excess electrons, generate a decarbonized fuel that we can store for months or even years, what does that do to a really isolated community? What if you took that decarbonized fuel, put it in a fuel cell that would produce both heat and electricity, and you put it next to a greenhouse? If you have heat and you have electricity for power, you can light it. So now that rural community could have food, it could have electricity, and it could have heat. Now you're going somewhere, and you're rethinking the paradigm of how we look at energy.
I would hope that in the future, my children live in a state where we have a robust electrical grid, where most of the energy we use on a day-to-day basis is all electrified. We're generating consistent, clean energy from wind and other sources to power that grid. We have an abundance of electric vehicles that are storing that energy.
What a better thing to bring green energy and materials at the same time, educate the next generation.
What we do matters. Each job matters a lot. It matters in the final outcome. It matters in the bigger scheme of humanity. It does matter.
At the end, I think innovation is about making our lives better.
Eventually, problems are solved. If they're important enough, you'll find other ways to do it.
None of us is smarter than all of us. The vision is that we have to work together to make a difference. It's not a job, it's a mission.